Section 3.2 is something we're going to call Hoy and Vux, and we'll explain that later. First, let's define some vocabulary. A solution of an equation in two variables, x and y, meaning x and y are the two variables that are in your equation. So again, a solution of an equation in two variables, x and y, is an ordered pair, x comma y. What this means is that if you were to substitute that x and that y value in of the ordered pair, it would produce a true statement when you plug them into the equation. The second vocabulary word, the graph of an equation in two variables. Again, when it means in two variables, that means you're going to have two variables in the equation, and typically they're going to be x and y. So again, just to reiterate, the graph of an equation in two variables is the set of points in a coordinate plane that represent all solutions of the equation. As we've seen in other sections, one way to graph an equation in two variables is to make a table of values like an XY chart, pick out x values for your domain, substitute those numbers into the equation, and figure out your y values, which would be the range of your equation, and then plot those ordered pairs and then connect the points to draw that straight line. And let's move on to our next vocabulary word. A linear equation is an equation whose graph is a line. If you look at the word linear, the root word of linear is line. So anytime you have a linear equation, you are going to have a straight line when you graph that equation. You guys have seen this in your AMs. It'll ask you which one of these equations is a linear function or a linear equation. So we're looking at the equations that if you were to graph them, you would get a straight line. So as we talked about before, a linear equation will always have x and y both in the first power. The x value cannot be in the denominator. It cannot be in a square root. It can't be in an absolute value. Nothing weird can be happening to the x value in order for you to state that this is a linear equation. And again, you can always check it by graphing it like in a graphing calculator and seeing if that equation will give you a straight line. If it does not give you a straight line, therefore it is not a linear equation. And our last vocabulary word, the standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, meaning not imaginary numbers, which again, we have never even covered what imaginary numbers are. So any number, a, b, and c can be. And a and b are both non-zero numbers, because if a was equal to 0, then your x term would go away. If b was equal to 0, then your y term would go away. So again, this is a standard form of a linear equation. And again, as I was stating before, x is in the first power and y is in the first power. Nothing is happening to the x value. It's not in a square root. It's not in absolute value bars. Nothing is happening to the x value other than it's just to the first power. We would go from a standard form equation like this into slope-intercept form just by simply solving for y. Let me give you an example of an equation in standard form. Let's do 3x plus 6y equals 12. So as you can see here, our a, b, and c values would be a is 3, b is 6, and c is 12. If I wanted to take this standard form equation and put it into slope-intercept form equation, y equals mx plus b, I would just need to solve for y. So I would do that by subtracting 3x. So I would end up with 6y equals, and you know I like to put the 3x first, so negative 3x plus 12, and then I would divide both sides by 6. Remember, I have to divide everything by 6. So now my new equation would be y equals negative 3 divided by positive 6, and lowest terms would be negative 1/2 x, and then 12 divided by 6 is 2. So now I have gone from my standard form, 3x plus 6y equals 12, into slope-intercept form by getting y by itself and getting y equals negative 1/2 x plus 2. So now I would be able to state that m is negative 1/2 and b, the y-intercept, is 2. I was not able to state that from the standard form. There is a time and a place where the standard form of an equation is helpful, but typically if you're given an equation in standard form like this, you will probably just want to get it into slope-intercept form where you get y by itself so that you're able to identify what the slope and the y-intercepts are so you can graph it. And now on to the part that this section actually is all about. This is the Hoy and Vux part. The graphic that I've given you is from the book, and it's how you are supposed to identify the horizontal and vertical line equations when you're given them. However, I'm going to give you an easy little mnemonic device in order to figure out when do you have a horizontal equation and when do you have a vertical equation, and that's where Hoy and Vux come into play. But let's first look at what the book has to say. So it says the graph of y equals b is a horizontal line that passes through the point 0, comma b. So for example, what they're saying is if you were given y equals 3, so the b value would be 3. That would mean that this is a horizontal line going through the y-axis at 3. So they would say that that point right there is 3. So a horizontal line is when it's y equals. A vertical line would be when you have x equals some number. So the graph of x equals a is a vertical line. The line passes through the point a, comma 0. So again, if they said x equals 3, you would be able to identify that that's a vertical line, and the place where it's hitting the x-axis at is at x equals 3. So this point right there would be 3. But again, I have an easy mnemonic device that you can use in order to remember when do you have a horizontal line and when do you have a vertical line. And again, that's where Hoy and Vux comes into play. So Hoy stands for this. H stands for horizontal. The O actually is a 0, and if you remember from the section over slope, the slope of a horizontal line is 0. And the Y represents the type of equation that you would get. If your equation is y equals some number, so like y equals 6, then you know that's a horizontal line. So again, the Y represents if your equation is y equals. So again, you can use Hoy to remember how to graph or how to identify a horizontal line. So remember, H represents horizontal. The O is actually a 0, and that's to remind you that the slope of a horizontal line is 0. And the Y is there to remind you that you have a horizontal line if your equation is y equals some number. The next is Vux. The V stands for vertical. The U is there to remind you that the slope of a vertical line is undefined. And the X is there to remind you that you have an equation of a vertical line if your equation is x equals some number. So again, you can use Vux in order to remember how to identify or how to graph an equation that is a vertical line. So remember, the V represents vertical. The U is for the fact that the slope is undefined, and an equation that's going to give you a vertical line would be in the form of x equals. So if it said x equals 3, then you know it's going to be a vertical line going through where x equals 3 on the x-axis. Example number 1, decide if the given ordered pair is a solution of negative x plus 2y equals 8. So if these two ordered pairs were a solution to that equation, if I took the x value and the y value from the ordered pair and substituted those in for the x and y values of the equation, it would give me a true statement. So let's do just that. So I'm going to take this negative 1 and the 4, put negative 1 in for x and the 4 in for y into the equation and see if I get a true statement. So our equation is negative x plus 2y equals 8. So remember, if I have a negative x, it's kind of like negative 1 times x. So when I plug negative 1 in, I have a double negative there. So it'd be like negative 1 times negative 1 for my x value plus 2 times 4, since I'm putting 4 in for y, equals 8. So negative 1 times negative 1 would be positive 1, plus 2 times 4 is 8, and 1 plus 8 is 9. I did not get a true statement, so therefore negative 1, 4 is not a solution to this equation. Plugging negative 2 and 3 in for our x and y values. So again, remember, negative x means like negative 1 times x. So when I put negative 2 in for x, I would have like negative 2 plus 2 times 3 equals 8. So negative times negative 2, so negative 1 times negative 2 is positive 2, plus 2 times 3 is 6, equals 8, and 2 plus 6 is 8. I did get a true statement. I got 8 equals 8, so therefore negative 2, 3 is a solution to that equation. And example number 2 wants us to graph y equals 3 and x equals -2. So let's think back to Hoy and Vux. The first equation is y equals 3. So I'm going to think of Hoy since Hoy ends with the y. So that means that y equals 3 would be a horizontal line, the slope would be 0, and it'd be y equals. So I'm going to draw a horizontal line through the y-axis where y is equal to 3. So on my graph, I'm going to count up 3 units to right here, where y is equal to 3, and just draw a straight line, a horizontal line, through where y equals 3. And that's what my line would look like. Next, I have x equals -2. So I'm going to go back to Vux. Since my equation is x equals, I'm going to do Vux. So that means I have a vertical line, the slope is undefined, and I'd have an x equals equation just like I have x equals -2. So that means I'm going to draw a vertical line through the x-axis where x equals -2. So I'm just going to go on the x-axis. Here's where x equals -2, and I'm going to draw a vertical line through it. And that's what my graph would look like. A vertical line going through x equals -2. That's it for the notes for today. Make sure you write down any questions that you might have over this before we move on with the section, and I'll see you then.